Hello everyone, this is me Steve. Welcome back to my YouTube channel, and in this video I'm going to share my learning note about Flink, basic concept and basic infrastructure. So let's start it. So what is Flink? So imagine that in a company they have real-time data coming into their systems, and then they want to utilize the real-time data into something that useful for them. For example, it has, let's say, purchase events, GPS events, or location events, or like live streaming events, and company want to utilize these real-time data into, let's say, to detect fraudulent activities, to real-time routing in the navigations or in the warehousing, usually in the e-commerce, and or to execute commands in IoT application based on sensors that they receive. So Flink can help them to build or to process the real-time data with streaming processing or with batching processing. The real use case example here in Gojek, they have application called Atlas. It's basically they use Flink to capture real events data, and then they use that events to visualize the demand and supply distribution in West Java in Indonesia. Right. So let's check the glossary. Stream processing. So in stream processing, it consists of two types of stream. The first one is bounded and unbounded. The second one is unbounded. Bounded means that it has the start of the stream and then end of the stream. It has start of the stream, it has end of the stream. Unbounded, it has start of the stream, but it doesn't have the end of the stream. So it will continuously consume the data technically until we shut down the systems. Okay, so there is no endpoint here. Sources and sinks. So here in the middle is the infrastructure of Gojek Atlas from their engineering block. The sources means that a starting point of the data streams. The function is to inject the data to Flink application. So in this example, their data streams, their sources is Kafka, which is consists of different events, supply events, demand events, right? It reads from these sources and injects it to Flink. And at the other hand, sinks is the endpoint of data streams, where the results of the Flink data processing are sent or stored. In this example, they store it in a database to be later visualized using their applications. So what is job? So job is a set of instructions that we submitted. It can be used programming language like that, or it can use Flink SQL, which is I haven't learned it, but I will learn it later. And then these instructions will consist of data ingestions, consists of data transformations, and where we output or the sinks. Okay, and then we submit this job to Flink. So that's what is job. And then the submitted data will be translated into a graph, which is called a job graph or logical graph or data flow graph. They refers to the same thing basically. And the graph has a pointer, so it's basically a DAG or directed acyclic graph. I have created a video about it, so you can check about that later. So this is the flow of the data. We'll start from the source and then end to the sink. Yeah, so this is the input, this is the output, this is the input, this is the output, where each step in the job corresponds to the vertex in this graph, right? So each step in this job corresponds to the vertex in this graph. And what is the operators? Operators are logical processing units that vertex will use to process the data streams. For example, to map, to filter, or to join the data. There are the types of operators. Source operators that handle about source, sink operator that handle about things, and transformation operator that handles how to transform the data. Okay, for example, this is the operators of transformations. That in this case, the operator is to flat the map using some kind of tokenization. Job manager. Job managers basically is like in Kubernetes is like a contour plane, or in Elasticsearch is like a master node. Yeah, to control or orchestrate the cluster of the Flink. It consists of three things. First is resource managers. It's basically to manage the resource of the computation in Flink clusters. Dispatchers is basically a gateway to Flink API. Okay, and Flink also has a web UI, so it will be served using a dispatcher components. And the third one is job master, where if we submit a job, Flink will create a job master. So if we have 5 jobs submitted, Flink will create 5 job master, where each job master will be managed by job will be managed by job masters to manage the job lifecycle. Execution or physical graph is basically from this job graph, it will be transformed into a graph where visualize how actually Flink will execute that in the runtime. Okay, so if job graph visualize about the job as an overview, as a visualization, but execution physical graph will be visualize how the job will be executed in the runtime. Alright, so execution graph is a parallelized version of the job graph, so it will show us level of execution parallelism in the runtime. Okay, for example, job vertex A is actually will be executed by 2 tasks in parallel, so this will be visible in execution graph, not in the job graph. Okay. Task is a smallest execution units running within a Flink cluster, which perform the work described by operators. Okay, so the operator describe the logical unit, how we want to read the data, how we want to transform the data, but the actual execution unit that will do the computation of that is a task. And a task is bound to a specific thread and runs within a task slot, which I will explain that later. So for example, job A, okay, it's consists of 2 tasks, right? Task 1 and task 2. Task manager. Task manager is a worker node to execute the individual tasks. So it's basically a worker node. Okay, and then each task manager can have 1 or more task slots, where task slots determine how many tasks that can be executed in parallel. So for example, in the right, I have one node of task managers. Okay, it has 1 core of CPU and 4 gigabytes of memory, and then from that, let's say we configured into 3 slots, 1, 2, 3, where each slot have its own resources, and it can run tasks in each job. So it's showing that how many tasks that can be executed in parallel, either from the same job or from different jobs. Okay, so what is operator chain? So operator chaining is a performance optimizations that allows the executions of multiple operations in a single task, thereby reducing the overhead of inter-task communication and context switching. So if you look at this graph, in this task manager, it has 3 tasks running on different slots, okay, on different threads. So if this task need to communicate with this task, right, then it requires external resources to deserialize and serialize, and also for context switching, because this is in parallel, right? The CPU needs to have context switching between slot 1 and slot 2 and slot 3 and slot 1 and slot 2 and so and continuously like that. So if we combine these 3 tasks into one slot, yeah, to be run in a one slot, the performance will be better, right? Of course, there is limitations, but basically those tasks that can be grouped into one slot that compatible each other will be grouped, and then this operator chaining, if I'm not mistaken, will be run automatically by Flink. But we also have access to manage it manually if you want. So this is my last slide about anatomy of Flink cluster. Alright, let's summarize what we have learned by looking at this anatomy. So first we have a Flink program, which is the program that we write. For example, using a Java, we write the step of procedures that we want to execute, and then we execute it, and then the program will convert that into data flow graph, which is visualizations of the jobs, and then the client, which is the program, will connect to the job manager through the dispatcher, because it has an API interface, to submit the job, and then it sends the data flow. Job manager will receive that job, and then it will use the resource manager to basically allocate the resource needed to execute the job. Let's say in this example we have 2 task managers, yeah. So the resource manager created 2 task managers, where in each task manager it has 3 task slots, and then these slots will be given to the job master. So then job master will basically deploy the task into this task slot to be executed by the worker. Okay, so this is the anatomy. There is so much going on inside here, like for example, how Flink handle the failure, right, about the job life cycle, the task life cycle, and how we can operate this kind of things. So I will create follow-up videos with demo, but for now that's it so far that I have learned. I hope I can share more video about Flink in the future. Thank you for watching. I see you in the next video. Bye bye.